So we're going to look at this section on direct variation. It's a continuation of that simple spring lab you did. One of the questions I got, which was a good question from a lot of you, was, hey, Mr. Howell, my data doesn't look like direct variation. And a few of you emailed me and said, it kind of goes up, but it's not the same every time. So the idea of the lab was that, you know what, if you put more weight on the spring, what's going to happen to it? It stretches further. That's the idea of direct variation. Something increases, the other thing also increases. What's an example of everyday life direct variation? As something increases, another thing increases. Give me an example. I can think of 100 easily. There are so many things to think of. Think of something that works that way. Yeah.
I mean, I guess this is kind of really easy, but it's like the more steps you take, the more footprints you leave behind.
Perfect. There you go. What else?
Or like when you pull a lever, the further you pull it down, the other thing, the higher the bend.
Perfect. On a lever or like some sort of pulley system. Agreed. The further you pull this, the further that rises up. What else? So many examples. I just want you all to think of one. That's why. Go.
The longer the light is up in the street, the more cars come through.
The longer, what was the beginning?
The light in the street is green.
The more cars are backed up. Or green. So the more flow through. Okay? Ed?
The longer you wait before you eat, the hungrier you get.
Agreed. What else? Is it good?
The more calories the more you eat, the more calories you consume.
Yeah, the more you eat, more calories you consume. Opposite of that?
When you run, more calories.
Yeah. Does it make sense, right? Is the idea? Yeah, go yours. Yeah.
Like the more yeast you put it, the more like the bread rises.
True. The more yeast, the more the bread rises. I agree. The more you study, hopefully the... Yeah, that's the one that I always say. I use that example and students give me this look like, I studied really hard on the last test, my grade went down actually, so I don't think that... But the concept is the study effort you put in should help you down the road. So that's direct variation. Tomorrow when you look, or tonight when you watch indirect, what do you think is going to happen? Good. One goes up, the other goes down. The thing we're going to see tonight, joint variation, is both. You could have one thing go up and another thing go down while something completely different changes. Okay? We'll see that tonight in the video. So let's go through today's lesson. So this is our general function. Does this look familiar to you? Where have you seen y equals something with x before? What kind of a function is this really? What type of a function did we call this earlier?
It was like we used to use it when we were graphing stuff.
Yeah.
What? That form.
Yeah, specifically, what were we graphing? Good. Mx plus b, lines. Very good. That's it. Thank you. So the idea here is that direct variation involves no y-intercept. So literally, just get rid of b. That's it, and you've got direct variation. Put a line through b, cross it off. That's direct variation. Y equals mx. Now, m stands for slope from the French word montagne, meaning mountains. It's ridiculous that we use m for slope still, but we do. So we'll keep it with m for now. But k is the same thing. K we call the constant of variation, or another word, the constant of proportionality. Why does proportionality make sense to use that word actually? The constant of proportionality.
Proportion is like the side of something regardless of something else.
So if one of them went up, what would happen to the other one?
It gets smaller or bigger.
Yeah, the other one has to change as a result, whether they're proportional directly or indirectly. They're comparing two things. That's what you're doing here. You're saying, you know what? If x is 2 and y is 8, what's my constant of proportionality? What's my k value? What must it be? 4. All right, well, if the constant is 4, and now I tell you that the x value goes up to 7, what does the y value become? 28. So since this 2 increased to 7, this 8 increased to 28. It's directly proportional to one another, so the word constant of variation of constant of proportionality is fine either way. It's fine either way. In the lab, what did you do? Fs, oh no, I didn't use Fs, I used, what did I use? M equals K delta X? Okay, because in physics it's Fs equals negative Kx. Same formula really. In your lab, the other day, we had this idea that if we increase the mass, delta X continued to increase. The stretch, the change in length, change, delta X length. The change in length of the spring kept increasing. The spring kept getting longer and longer and longer as the mass kept increasing. What was K called? Our constant of variation. In physics, K is called your spring constant. Spring constant. I use the spring for a reason. When you get to physics, you'll see a lot more why. But the idea, so you know, is that everything that's some material can be modeled with a spring. Literally everything. And it's scary to think about that. But everything you could think of could be modeled with a spring. And a simple example would be like an airbag. Airbags, are there springs in airbags? No, there are not. But if you think about it, you hit the brakes, your airbag deploys as you're about to hit the windshield, or you hit the windshield. What does the airbag do? It like cushions you, right? It absorbs the shock. What does a spring do? The same thing. Ever jump up and down on a pogo stick? The pogo stick is taking your potential energy, storing it in a spring, and then launching you back up. It's literally conversion of energy, or it's a spring absorbing the shock. A lot of things are modeled by springs. That's why I use the spring for this lab. And also because it does kind of follow direct variation. Take a look at this first one, please. Try this on your own. Use the general equation we just wrote down. Okay, use the general equation and follow the simple directions. Given the scenario above, the directions say, given the following scenario, find the constant of proportionality. Then find the value of x if y is 18. First, I want you to find the constant of proportionality. You could find the answer to the second part without the first part, by the way. You can easily find out what x is without having k. But I want you to find k first. So I'm either starting it already or looking up here. If I'm already starting, keep going, please, if you want to look up. I see this. X is 4 and y is 24. So I literally just plug that in. Oops. So what's the constant of proportionality, everybody? 6. If that's the case, I now write my equation like this. Let's write this down if you don't have this written down. This is called the direct variation general function. This is I call the specific function. Meaning this is specific to what? The scenario that was given. The scenario was given that 24 is y when 4 is x, which yielded 6 to be k. So this is a specific function for this instance, where k is 6. Now, I then look and say, all right, well, I've got the constant proportionality, check, that's done. But then it says, find the value of x when y is 18. So if y is 18, what must x be?
3.
X is indeed 3. Now, pause for a second. Even if you're moving on to the second problem, pause and look back at this one. Our answer is 3 for x. Can somebody tell me how to get that answer without having to do all this work? If you're on the SAT, it's a lot of work. If I just need to get x, how can I get x if I know the things are directly related? What could I do?
Or you could just like y over x. That's it.
Equals
Equals y.
equals y over x. Set up a,
Proportion.
what was the word? You used it earlier.
Proportion.
A proportion. Remember you used the word proportion earlier? So set up a proportion. So the first scenario told us that y was 24 when x was 4. And the second scenario said y is 18 and what is x? So you could also do this. Use a proportion. Y over x equals y over x. That's what direct variation is. And clearly you can see 24 over 4. What does that give you? 6. That's the k value, isn't it? So 18 over what must give you 6? It must be 3. Okay, or you can do what? How do you solve a proportion easily? If you can't see the answer, what do you do always? Cross multiply. Cross multiply. Okay, you'd get 24x equals 72. Right? 24 times x equals 18 times 4, or 72. X would become 3. The same answer we get by doing it the way we had prescribed in the problem. Again, I'm only bugging you to find the k value so you understand what the constant of proportionality actually is. Questions? No? All right, example 2, more applicable, right? A little bit more applicable than the last one where it's just random numbers. Try this one on your own. I'm going to start turning back some of your work to make it easier to do this now, in case we do run out of time. Maybe not. Maybe. So remember there were 2 parts to this test. Okay, there were 2 parts to it. So you're going to get 2 parts. think I showed you these tests already, but Max was out, so I didn't let you keep them. This probably shouldn't be, right? Isn't that right? Because Max was out, I didn't let anyone keep them for that reason. Isn't that? Homework and quizzes, if I still have any of your stuff. Yours. Here. A couple of really post-perfect grades. Some up there, perfect. Well done overall. All right, so what do we shoot for this quarter? We started with 85, right? Quarter one. Quarter two is 87.5. Quarter three was a 90, so let's shoot for a 92.5 as a class this quarter. So for a 92.5. All right, what do we got for this? Give me a setup, bridge. Give me something you started with, some sort of an equation, preferably. Good, I like that. See what Bridge did? He said, you know what, I can use y and x, but this problem says p and w, so I'm going to be smart and use p and w because p stands for paycheck. W stands for worked hours, or whatever, work. All right, good. After that, Luke, what do?
You do 96 equals 12K.
Why?
Because P equals his paycheck, and his paycheck is $96, and W equals hours worked, because hours worked is 12 hours.
And so, Luke, real quick, before we go further, even if you didn't have words, what could be indicating factors of where it goes what? The what of the number?
You can sort of tell the values of the numbers because the number on the right is usually a divisible, like a number divisible by the number.
Don't make that assumption, but I like that still, but there's something else that helps. Look, I highlighted, Luke, what do you think? See what I highlighted? Why did I highlight not just the number? What else did I highlight?
The units.
Yeah.
Units. Thank you. Units. Science. Come on, science. All about units. So if for some reason you have no idea what goes where, and you have the units alone, 12 hours. Hours is amount of work. Use the units to help you, please. And the question says, what's his paycheck for 17 hours? So I could find K. What's the hourly rate? What does the hourly rate turn out to be? K is the hourly rate when you think about it, right? $8 per
hour.
Thank you. Because think, these are dollars and these are hours. Please, I need you to understand these units. They need to make sense. You need to understand the physical context if you're going to do well is like a calculus kind of student later in school. In engineering, in science, you got to get units. 96 is dollars divided by 12 hours is dollars per hour. You should recognize on your own, I kind of gave it away accidentally, that this is the hourly rate. The hourly rate. Okay, so if you have your hourly rate and you go into work tomorrow and you work 17 hours, you just multiply those, right? And you get how much you make. Well, where's the multiplication come from? It comes from this equation. I now have the equation P equals 8W. I know I worked 17 hours. I plug 17 in and it turns out it really is just multiplication. Hourly rate times the amount of hours worked. Units, please. Units. Ready? Dollars per hour, 17 hours. My answer, what happens to hours? Yeah, because one's up top and one's down below, just like X over X. So my units of my answer have to be only dollars. This dollars from right here. It makes sense because you're trying to find out your paycheck. Your paycheck is measured in dollars. 8 times 17, something with 6.
136.
There you go. Again, how else could we have solved this? We know that $96 is gained by working 12 hours. So how many dollars is gained by working 17 hours? Here's your alternate solution on the top right. If you are taking an SAT exam, these questions are on every single exam. Direct variation, indirect variation. Please, if you're taking an SAT, just do this. Isn't this faster? Cross multiply, solve versus reduce. It's so much faster this way than writing out every single equation. Now, if you're doing something with joint variation, which you're going to see tonight, or indirect and direct at the same time, it will be useful to write it out. But if you have a scenario where it's pretty simple, and you know the proportion, just write the proportion out and solve it. It's faster on the SAT than doing all this work. Okay? Questions so far on this one? Oops. So, Hannah, why is the b cubed and not the k?
Because A is directly proportional to what we
Yeah, it's not k, right? It doesn't say k. The common mistake here I see is that students either put kb in parentheses and cube the whole thing, or they cube both k and b or just k. B is the only thing that's being cubed because it's directly proportional to the cube of b. The word doesn't say cube of b, but I can write a question to you that says, y is directly proportional to the square of x. Y equals kx squared. Okay, so you have to consider what you're being given. So that's why this one can be a little bit trickier, but after this, you're done. This is easy. You just plug your numbers in here, it's it. Can you use a proportion here? If, and even if you're going to say yes. The answer to me would be no, but you can if something. Yeah, you have to take care of the cubing portion. So I would not use a proportion here because a lot of students would use a proportion and just say something like, oh, A is 10, B is 2 right here, and that equals, all right, well, I'm trying to find A, so I don't know what that is when B is 4. And this would be the common mistake that students would just use this right here. But in reality, what do they have to really do? They have to cube B, right? So we'd have to cube these, and it's a little bit more of a headache. Not really, but it could be a mistake. So let's use the direct variation equation for now. So when A is 10, we're told that B is 2. So Luke, to argue against him earlier, it's clearly not always, right? So what does K become in this case? 1.25. Okay, K is 1.25, or you can write it as a fraction, 1/4 or 5/4. Either way is fine. If that's the case, I know my specific equation now is this. Remember, this was the general function, this is the specific function. Once you get K, just plug it in. Now we're trying to find out what A is when B is 4. It's really easy, just plug in a 4 for B. Four cubed. Good. 1.25 by 64. Very good. Okay. 64 is 4/16, so I had 16 of that.
How could it be 1.25 if 8 doesn't even go? Or, yeah, it does. Never mind. I'm doing math.
You did 8/10.
Yeah.
Yep, that's fine. What? Let's see. We can solve this one also just to continue, right? The other approach. We get 10/8 equals A over 64. Here's how I would do this. Ready? Quick answer. How do you know A is 80 by just looking at this without cross multiplying? Come on, figure it out. Figure it out. No cross multiplication allowed. How do you figure it out?
They both multiply by 8.
Yeah. 8 times 8 gives you 64. 10 times 8 gives you 80. Okay, you can see that this, to get from here to here, you have to multiply by 8. To get from here to here, it's got to multiply by 8. A is 80. So A is 80. But again, I don't encourage proportions when it's directly related to the square or the cube or something different, because people forget to do that in the bottom here. And then they don't know which one do I do, the bottom or the top. The reason I did it in the bottom was because it's the proportional to the cube of B, and B was 2, so I cubed that, and then B was 4, so I cubed that. That's how I know to use those ones to cube there. But I again recommend that when you have something a little more complicated than just direct variation, like this is a little more complicated, please don't use that. Questions on this one? How about the last one? Let's take a look at that. This is right out of physics. This is stuff we use this year. We just covered this in 2 chapters ago. The period of a pendulum that oscillates back and forth is directly proportional to the square root of the length of the pendulum. The period, again, is directly proportional to the square root of the length of the pendulum. Stop there. Write your equation. First sentence only, please. First sentence only. Write out your equation. And the key is what's in blue, really. What do you want to call a period in this one? What letter? Really doesn't matter. Go ahead, Annette. Let's call it P for period. That makes sense. The period is. Right? I'm taking English and converting to math. P equals means the period is. What else? Good.
K times square root of L.
Very good. And L is traditionally written as strict, by the way. If it's uppercase, lowercase. It's uppercase, you can put print L. Okay? Why do I do that, obviously?
It looks like 1.
Yeah. Okay, L looks like 1 for right now. That's why Z is not used very often, actually, because Z kind of looks like 2 also. And S looks like 5. No, it's not. Anyway, that's the equation. P equals K root L. Because P is, right? P is directly related to the square root of L. I'm literally taking a sentence and I'm breaking down all the components of that sentence and writing the equation. So the period of a pendulum, well, that goes to become P, is, means equal, directly proportional to, means K, and then the square of the length of the square root of the length of the pendulum means root L. So I literally have all of that above. P equals K root L. But I'm taking the parts of the sentence and making that work. The next part is the easy part again. If a pendulum 64 centimeters long, that represents its what? Length. Has a period of 1.6 seconds, then what is the period of a pendulum that's 100 centimeters long? So sure, yes, we can go to the proportion again on the right. If we want to do that, we could do that, but it's really messy. It's like, all right, period over square root of length equals the period we're looking for over the square root of the length. This one happens to be real nice because you got perfect squares. But that's the proportion we would write for this kind of a problem. Or just go ahead and solve this equation. K should be what, 0.2? What's K turn out to be here? 0.2? So I write my specific equation now. Remember here, this is the general function or general equation, and this is specific to this scenario. I know the length is 100 now, and we're trying to figure out what the period is. Square root of 100 is just 10. 10 times 0.2 is just 2. And my units are seconds. Period was given in seconds to start, right? 1.6 was given in seconds, so the period again has to be in seconds. Solve this up here. It's the same exact thing. Solve this one on the top right. This becomes 1.6 over 8 equals P over 10. Now is when I would cross multiply really here. I'd cross multiply, which would give me 16, right? 1.6 times 10 is 16 equals 8P. So P would equal 2. Same answer either way. Okay? Again, same answer, but remembering that you need to square root part of your proportion for it to work in this case. Next time you're going 2 minutes. Questions on this topic in general? No? Good. So tonight, yeah.
I just have a question about the homework.
Okay.
So if we see that a problem is extremely easy and we can just easily do with proportions, can we just do that?
Absolutely, yeah. Take the root that's best, but please practice a couple this way still. And a couple are going to be related to the square of something or square root or cube root. Might say it's directly related to the cube root, so that becomes a cube root instead of a square root. In those cases, try to write it out. Okay, your homework's a little bit lengthy. Here's the deal. Listen, if it becomes a thing of you have so much work tonight that you'd rather get the video done, definitely get the video done. And then tomorrow in class, you could probably do 8.1 and 8.2 homework if you really needed to. You follow what I'm saying? Okay? So use your judgment here. If you have a lot of work in the classes tonight, it's not the end of the world. At least definitely watch the video, because then tomorrow in class you can't do anything, right? So definitely watch A2 tonight. Try to get to this homework at least. But if not, you can do tomorrow in class with the A2 homework also. Right? Ashley and Gail, let me go over the thing I need you guys to work on real quick.